in this video, we're going to talk about the properties of real numbers. So first, let's talk about the set of real numbers. So this is a really good visual down here. There's also examples on the next couple of slides. So let's start with natural numbers. Natural numbers are the numbers you learn when you're small and you're counting. 1, 2, 3, 4, 5, 6, and so on. Now, if you add 0 to that, that would be the natural numbers plus 0 equals whole numbers. Okay, and that's 0, 1, 2, 3, 4. Now, if we add negative numbers, then we have integers. All of these together make up integers. Now, when we talk about fractions and decimals, then those would be rational numbers. Okay? Now, remember, these are the fractions and decimals that are either terminating or repeating. Irrational numbers are in a class all to themselves over here. Those are the radicals or fractions that, when you put them in decimal representation, those do not repeat and they do not terminate. They do not end. So let's look at this a little closer. Natural numbers, it shows these are your counting numbers, the ones you learned to count with. So that's the examples. Whole numbers, you add 0 to this list. Integers, we added the negatives here. So it would look like this. This is an example. Rational numbers, those are the fractions, the decimals that are repeating. So these can be either terminating or repeating decimals when you change them to decimal form. So remember, it includes everything we've talked about, plus we're adding terminating and repeating decimals. Irrational numbers are a class all to themselves. Those are the radicals or numbers like pi, anything that does not repeat and does not end. So let's do an example, okay? First of all, I like to look at these and change them to a decimal if I need to. Like this would be a negative 0.75. So I know that's a terminating decimal. This one is repeating. Square root of 5, if you plug it in to a calculator, it does not repeat, it does not end, and neither does pi. So pick out your irrational numbers first. This one is a terminating decimal. Now, square root of 81 is 9. Okay? Now that we know everything, let's go down and look. So we're going to pick out natural numbers from this list, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Let's look on the next slide. Now we did identify these as irrational. We identified this as negative 0.75, and this one is 9. So for natural numbers, when you look through this list, the only natural number would be 9. For whole numbers, we would add 0 to that. For integers, okay, so we've got the 0, we've got the 9. We also need to add the negative numbers, okay? Now remember, integers aren't written as decimals, okay? So that's a negative number. Negative 7 is an integer. For rational numbers, we include everything we've got so far, and then we go back and we pick up these terminating and repeating decimals. So we're going to add negative 3/4, and we're going to add the 0.6 repeating, and we're going to add the 7.3. Irrational numbers, it's always easier to identify those in the very beginning. These are the ones that do not terminate, do not repeat. And when it says real numbers, that's everything you see. Let's talk about some properties here. So the first one says closure property of addition. It basically says if you add any two real numbers, you're going to get a real number. This also works for multiplication. If you multiply two real numbers, you're going to get a real number. So that's called the closure property of multiplication. Commutative property works for addition and multiplication. And what that says is it doesn't matter about your order. If you add a plus b and b plus a, you're going to get the same thing. So for multiplication and addition, order does not matter. Associative property for addition and multiplication. That means if you move your parentheses, like you do a plus b, then add c, or you do b plus c first, then add a, you're going to get the exact same number. So your grouping symbols can move. Okay? Distributive property, when you have one number on the outside, you can do a times b plus a times c. That one's called distributive property. Identity property of addition, if you add 0 to a number, you get what you started with. So that is called the identity property. Identity property for multiplication, if you multiply by 1, you get what you started with. And the last two we're going to look at are inverse property. Inverse property for addition, you want to add the opposite. So a plus negative a would be 0. Or negative pi plus positive pi would be 0. The inverse property for multiplication means you're going to multiply by the reciprocal. So a times 1 over a equals 1. 1 over pi times pi equals 1. So let's look at these and identify them. This one, all they did was change the order. So they did the commutative property of multiplication. Let's look at this one. See how the parentheses actually moved and they're around two different numbers? That would be the associative property of addition. Here they distributed, so that's the distributive property of multiplication over addition. On this one, you guys, they didn't move the parentheses, okay? They didn't include square root of 2. See how they just switched those two numbers? So that would be commutative property. Associative is when you move the parentheses. Here they added the opposite, that's the inverse property of addition. And on this one, they multiplied by 1, so that's the identity property of multiplication.